Right now, hidden behind the sun, an object from another star system just completed the most critical moment of its journey through our solar system. And what scientists are discovering about it is rewriting everything we thought we knew about interstellar visitors. What if I told you that this object, traveling at impossible speeds with a composition that shouldn't exist naturally, arrived at the perfect moment to visit 3 planets while remaining invisible from Earth during its closest approach to the Sun? The chances of this happening randomly are less than winning the lottery 5 times in a row. Yesterday morning at 7:47 Eastern Time on October 29th, the interstellar object known as 3I Atlas reached Perihelion, its closest point to our star. While the entire astronomical community held its breath, this visitor from beyond completed the acid test that would reveal its true nature. Atlas is now at a distance of 203 million kilometers from the Sun, exposed to intense solar radiation that should tear apart any loosely bound natural comet. At perihelion, the object is being bombarded by 770 watts per square meter of solar radiation. If this were an ordinary comet, held together by ice and weak gravitational forces, it should be fragmenting right now, breaking apart into a spectacular fireworks display of gas and dust. But there's a problem. At the exact moment when we need to observe it most, 3I Atlas cannot be observed from Earth at this opportune time, which raises the question of whether its trajectory was fine-tuned by extraterrestrial intelligence. Since October 21st, when it passed through solar conjunction, the object has been completely concealed behind our star from Earth's perspective. This is where the story gets interesting. Astrophysicist Avi Loeb has been tracking what he calls a series of anomalies, unusual characteristics that have earned this object a rank of 4 on the scale he created to assess whether interstellar objects might be technological in origin, where 0 means definitely natural and 10 means definitely artificial. Recent observations reveal rapid brightening and a color bluer than the sun. Think about that for a moment. The surface of the object is expected to be an order of magnitude colder than the 5,800 degrees Kelvin at the photosphere of the sun, resulting in it having a redder color. Yet somehow, against all physics we understand, 3I Atlas appears bluer than the sun. Loeb asks the question that's echoing through research labs worldwide. Does it employ a power source hotter than our star? Let's break down why scientists are so puzzled. 3I Atlas has 8 surprising properties. Its trajectory is aligned to within 5 degrees with the ecliptic plane of the planets around the Sun, with a likelihood of only 0.2%. Imagine a cosmic highway where all our planets travel on the same level. An interstellar visitor should come from any random direction in 3-dimensional space. Yet this one arrived almost perfectly aligned with our planetary plane. During July and August 2025, it displayed a sunward jet that is not an optical illusion from geometric perspective, unlike familiar comets. Normal comets always develop tails pointing away from the sun, pushed by solar radiation like a flag in the wind. This object created a jet pointing toward the sun, defying one of the most fundamental behaviors we've ever observed in comets. Its nucleus is about 1 million times more massive than 1I Oumuamua and 1,000 times more massive than 2I Borisov, while moving faster than both, altogether with a likelihood of less than 0.1%. It's like discovering a massive cargo ship moving faster than speedboats. The physics of how objects get ejected from star systems means larger objects typically move slower. 3I Atlas breaks this rule spectacularly. Its arrival time was fine-tuned to bring it within tens of millions of kilometers from Mars, Venus and Jupiter, and be unobservable from Earth. The object passed Mars at a distance of 28 million kilometers on October 3, 2025. After Perihelion, it will pass 97 million kilometers from Venus on November 3, 2025, and then 54 million kilometers from Jupiter on March 16, 2026. Yet during its perihelion, the most important observational moment, it remains hidden from Earth-based telescopes. The composition is equally puzzling. Recent analyses suggest that 3I Atlas contains unusually high concentrations of carbon dioxide and nickel. This metallic composition differs dramatically from what we expect in natural comets, which are typically described as dirty snowballs made mostly of water ice. The specific mixture of materials found in 3I Atlas resembles industrial alloys more than random cosmic debris. Fortunately, a network of space-based observatories has been tracking this object during its closest approach. The observations were taken by STEREO, the Solar Terrestrial Relations Observatory, consisting of spacecraft launched in 2006, along with NASA's Solar and Heliospheric Observatory and the GOES-19 weather satellite. These instruments occupy different positions in space, giving scientists multiple viewing angles while Earth's perspective remains blocked. What happens at perihelion matters enormously for understanding this object. In astronautics, there's something called the Oberth effect. The optimal point for a maneuver to speed up or slow down a spacecraft is at closest approach to a massive object. If 3I Atlas were a spacecraft, now would be the perfect moment to fire engines for maximum efficiency or to release smaller probes that could use the sun's gravity to slingshot toward the planet's Congresswoman Anna Paulina Luna is graciously helping to get the high-rise images of 3I Atlas from October 2, 2025, released to the scientific community. Radio observers around the world are monitoring the object continuously. If 3I Atlas maneuvers, releases mini probes, or transmits radio signals, then we will know that it is technological in origin. Other technological signatures include artificial lights or excess heat from an engine. Scientists are watching for any signs of deliberate behavior, any indication that this object is more than just a comet from another star system. The observations from multiple spacecraft during this critical period will be analyzed with unprecedented scrutiny. The natural explanation remains the most likely. If 3I Atlas is a natural comet glued together by weak forces, its heating by 770 watts per square meter at perihelion may break it up into fragments which evaporate more quickly. This fragmentation would produce a much brighter plume of gas and dust, which could explain some of the unusual brightness changes that have been observed. But the coincidences keep adding up. This unfavorable geometry of opposition from Earth, a possible hint of design, placed 3I Atlas within the fields of view of several space-based solar coronagraphs. The object's trajectory ensures it can be studied by space-based instruments while remaining hidden from the most powerful telescopes humanity has ever built on. Earth 3I Atlas will return to Earth's eastern pre-dawn sky for telescopic observers around November 11th. You'll need at least an 8-inch telescope to see it, as the comet will never become visible to the naked eye. On December 19, 2025, it will make its closest approach to Earth at a distance of 269 million kilometers. As it arrives at closest approach to Earth on December 19, 2025, ground-based observations as well as data from the Hubble and Webb space telescopes during the month of December will be able to characterize 3I Atlas in great detail. This represents our best and possibly only chance to study this interstellar visitor with our most advanced instruments before it leaves our solar system forever. The new data suggests that 3I Atlas will likely emerge from Perihelion brighter than before. If this prediction proves correct, it will add yet another layer to the mystery surrounding this object. Let me be clear about something important. 3I Atlas is most likely a comet of natural origin, but there are 8 anomalies that endow it with a rank of 4 on the Loeb scale. The scientific method requires us to follow evidence, not expectations or wishes. These anomalies deserve serious investigation precisely because they challenge our understanding. The mathematics are striking. When you multiply the individual probabilities of all these unusual characteristics occurring together by chance, the numbers become vanishingly small. It's statistically more improbable than many events we would never expect to see in our lifetimes. We have to collect as much data as possible to figure out the nature of this anomalous object. That's what science demands. Not jumping to conclusions, but gathering evidence, testing hypotheses, and following the data wherever it leads. Think about what we're witnessing. Only 3 confirmed interstellar objects have ever been detected passing through our solar system. The first, Oumuamua, arrived in 2017 and sparked intense debate about its peculiar elongated shape and unusual acceleration. The second Borisov appeared in 2019 and behaved much more like a typical comet. Now we have 3I Atlas, displaying characteristics that fall somewhere between the mundane and the extraordinary. Unlike 1I Oumuamua, which was only seen on its way out of the solar system, 3I Atlas was discovered while it was still 4.5 AU out from the Sun. This gave scientists months to study its approach, document its behavior, and prepare observing campaigns. The wealth of data being collected is unprecedented for an interstellar visitor. The coming weeks will be crucial. As 3I Atlas emerges from behind the Sun and returns to visibility, telescopes around the world will turn toward this cosmic visitor. Every measurement of its brightness, every spectral analysis of its composition, every image capturing its structure will be scrutinized for clues about its origin and nature. If the object fragments as it moves away from perihelion, that would support the natural comet hypothesis. If it maintains structural integrity despite the extreme heating it just endured, that raises more questions. If its brightness continues to change in unexpected ways, scientists will need to develop new models to explain the behavior. The possibility of detecting technological signatures remains remote but real. Any sign of deliberate maneuvering, any radio transmission, any behavior that cannot be explained by natural processes would represent one of the most significant discoveries in human history. The implications would extend far beyond astronomy, touching every aspect of how we understand our place in the universe. Even if 3I Atlas turns out to be entirely natural, the questions it raises are valuable. Why does its composition differ so dramatically from solar system comets? What processes in other star systems could produce objects with these characteristics? How common are interstellar visitors, and how many might we be missing with our current detection capabilities? With systems such as the Vera C. Rubin telescope just now coming online in 2025 and scouring the sky down to ever fainter magnitudes, We might start seeing lots more smaller, fainter interstellar objects slipping through our solar system very soon. Each detection will add to our understanding of the galaxy's population of wandering objects. For now, 3i Atlas continues its journey, temporarily hidden from Earth's view, but monitored by spacecraft positioned throughout the inner solar system. The data they're collecting during these crucial days will be analyzed for months or years to come. We're living through a unique moment in astronomical history. For the first time, humanity has the technology to study an interstellar visitor in detail from discovery through its entire passage past the Sun. Whether 3i Atlas proves to be a natural comet with unusual properties or something more extraordinary, the investigation itself represents a triumph of human curiosity and scientific capability. The next 50 days will provide answers. December's observations with Hubble and Webb, the continued monitoring by ground-based telescopes, and the analysis of data from solar observatories will either explain the anomalies through natural processes or deepen the mystery even further. Stay tuned, because we're watching history unfold in real time. An object from another star system, possibly billions of years old, is passing through our cosmic neighborhood right now. And we have front-row seats to one of the most intriguing astronomical investigations of our generation. The universe keeps its secrets well, but every now and then it sends us visitors that challenge everything we think we know. 3i Atlas is one of those visitors. Whether it's an exotic comet unlike anything we've seen before or something even more remarkable, we're about to find out.